Designing fault-tolerant systems. All right, let's just dive straight into this one. I want you to imagine for a second that you are checking out on a massive e-commerce site on Black Friday. You've been waiting all week for this exact deal.
You finally hit that purchase button on a brand new $1,000 TV. But exactly at that specific millisecond, the physical server processing your order literally catches fire in the data center. I'm talking motherboards frying, cables melting. That machine is completely, 100% dead.
So what happens next? Does your screen just suddenly freeze up? Do you actually lose your money? Or does the order just somehow go through completely normally? Think about that for a second, because the difference between those outcomes is exactly what we're looking at in today's explainer fault tolerance.
Let's start from zero here. At the end of the day, servers are just computers. And we all know computers break. Network cables get accidentally cut, and sometimes entire data centers just lose power. If your architecture relies on one single server to do its job, well, that is called a single point of failure. When that server dies, your business dies with it. Designing resilient architectures is entirely about mitigating those single points of failure so your application can actually survive the chaos. Section 1. High availability versus fault tolerance. Let's look at the core differences between these two concepts. High availability essentially means the system might actually go down, but it recovers incredibly fast. The user is definitely going to experience a brief interruption. Maybe they see a loading spinner, a slight delay, or maybe a quick retry screen, but eventually the system does recover and gets back to normal.
Fault tolerance, on the other hand, means the system never stops. It literally tolerates the failure with absolutely zero interruption to the end user. Traffic is instantly rerouted to backup systems, and the user experience continues seamlessly. They have absolutely no idea anything went wrong behind the scenes.
Think about it like driving a vehicle. High availability is basically a standard car with a spare tire. If you blow a tire, you have to pull over, jack up the car, and physically change it. Sure, it saves you from being completely stranded, but there is a clear, noticeable delay. Your trip was interrupted. Fault tolerance is driving a massive 18-wheeler truck. If one of those tires completely blows out on the highway at 70 miles an hour, the driver doesn't even have to tap the brakes. The other 17 tires instantly absorb all that massive weight. The truck just keeps driving like nothing happened. Section 2. Building the 18-wheeler in AWS. Let's see how we actually build this 18-wheeler truck in the cloud. Because if you don't use this strategy, a single hardware failure is going to cause dropped transactions, corrupted databases, and massive brand damage. We do this by using what AWS calls availability zones. An availability zone is simply a physically separated data center with its own independent power and its own independent cooling. You put your main servers over in Zone A, then you put redundant exact clone servers over in Zone B.
But here's the thing. Servers can't do this alone. You need a traffic cop. So you put an application load balancer right in front of them. This load balancer is constantly pinging the servers, basically asking, hey, are you healthy? Are you still there?
Now, imagine this happening in your system. The load balancer detects that a server in Zone A just crashed. It stops sending traffic there in a fraction of a second, and it silently reroutes all new traffic straight over to the surviving servers in Zone B. The system isn't actually invincible. It just hides the failure perfectly from the end user. Let that sink in for a second. That is the real magic of this architecture. Section 3. The cost of perfection. And listen, this is where people completely mess up in the real world. Building true fault tolerance is incredibly complex. Think about it. If server A dies right in the middle of a transaction, server B needs to know exactly what was in that user's shopping cart so it can immediately take over. That means you absolutely cannot store user data on the compute servers themselves. You have to design stateless workloads. You push that cart data to external databases or caching layers, completely decoupling the stateful data so backend processing can happen at its own pace. Doing this changes your entire engineering codebase. It is also absolutely brutal on your budget. You are paying out of pocket to run duplicate servers and duplicate databases across multiple zones. If you blindly make every single application perfectly fault-tolerant, you will bankrupt your company. You only choose true fault tolerance for mission-critical systems, things like payment processors, healthcare records, stock trading platforms, systems where dropping one single transaction literally costs $1 million or ruins someone's life. For basic internal tools, a 3-minute hiccup is annoying, sure, but it's totally fine. So, the crucial point to remember is that fault tolerance isn't just a cool IT feature, it is a massive financial insurance policy, and you pay for that policy with heavy cloud infrastructure.
Section 4. AWS Exam Strategy. Here are a few quick tips for the test. If you are a focused learner currently studying for the AWS Solutions Architect exam, pay really close attention here. AWS will definitely try to trick you.
Designing resilient architectures makes up 26% of your entire test. This is what actually matters for passing.
If an exam question asks how to implement a fault-tolerant architecture to mitigate a single point of failure, do not pick the answer that just says, take daily backups. Backups are just data recovery. They absolutely do not keep the site online. Do pick the answer that combines an application load balancer with an auto-scaling group spread across multiple availability zones.
And if the question scales up to global disaster recovery across entire regions, you need to look for Amazon Route 53. That is the critical answer to manage that massive failover traffic.
Section 5. Rapid Fire Takeaways. Let's do a really fast, punchy recap to lock this all in.
Remember, high availability is recovering fast, while fault tolerance is never going down. We achieve this by spreading redundant infrastructure across multiple AWS availability zones and load balancing the traffic. Here are your 3 rapid-fire takeaways. 1. Single points of failure are the absolute biggest enemy in your cloud architecture. 2. True fault tolerance requires decoupling your stateful data from your compute servers. 3. Application load balancers and Amazon Route 553 are the critical routing mechanisms that make that failover completely invisible to your users.
And here is your final warning for today. Are you buying an 18-wheeler just to go get groceries? Do not over-engineer. Building a perfectly fault-tolerant architecture for a simple personal blog is exactly like that. Always match your cloud architecture to your actual business risk. Keep learning, keep building, and make sure you're always designing for the real world.